Hello viewer, welcome again to another aspect of motion. Today we are going to discuss frictional force. Please don't forget we have looked at the causes of motion. Under that causes of motion, we say the agent responsible for it is a force. And we also discussed the two types of force. Under that two types of force, I think we look at some of the example under it, which is the frictional force and tension, force of push and force of pull. But now I want to focus on one today, which is a frictional force. We want to focus on frictional force today. Now, what is friction? By the way, what is friction? Friction is a force that resists motion. Please don't forget, any force that opposes motion is said to be a frictional force. It means that if this force exists between two surfaces in contact, it means that this force exists between two surfaces in contact. Now, let's now look at it now. I want to look at the two types of friction. There are two types of friction, please don't forget. There are two types of friction. We have the limiting friction. Two types of friction. We have limiting friction, limiting or static friction. Either you call it limiting or static friction. Another type of friction is dynamic friction or kinetic friction. These are the two types of friction we have under this section today. Okay, now we want to discuss them one after the other. Now, looking at it now, we want to consider a free body diagram. Let us look at that now. Assuming now, okay, let us consider a free body diagram. Let us look at that. A free body diagram. Let us look at that. We want to look at a free body diagram. Let us look at that. Now, assuming I have a floor and there is a concrete block on it. Assuming I have a floor and there is a concrete block on it. How we can see? Assuming I have a floor and there is what? A concrete block on it. Now, in this one, in this block, you know that it exert a force, and that force is known as W, which is weight. This one is known as W, which is weight, and is energy. And we also have another force that will be acting upward, and this one is the normal force. And sometimes we can call it normal reaction. It means that this one is the normal force or the normal reaction. Okay, now on this point, now I want to see. I want to leave this body like that. I don't want to touch the body. I don't want to push it. I don't want to touch. I don't want to push it. Now to determine what will be the force, what will be the sum of the forces on this system. If, for instance, I'm not pushing it, I'm not touching it, the body is like this. Now, what will be the sum of the force on this system? It means that the sum of this force, it means that I'm going to resolve this system into two components. Meaning, the sum of the forces on this system, I will resolve into what? Two components, which is the x component and what? The y component. Let's now look at the first one, which is the x component. That is going to be what? Fs, which is the x component. And I'm going to be having, okay, you can see now there is no force opposing it. Look at it, there is no force opposing it. It means that the body is just like that, nothing is, I'm not pushing. The only way we can have an opposing force is when we push, is when we try to apply the force. Since I'm not applying the force now, I want to allow this body to remain like this. It means that the sum of these forces on the S will be what? NAS. We want what? NAS. Please don't forget that is some of the forces on the X, the sum of the forces on the S axis. Some of the forces on the S axis. Some of the forces on the S axis. Okay, let us see. Now, from what we have here, since the sum of the forces is this on the S axis, it means that since the body is not moving, it's just static. Please don't forget, this body is static. This body is not moving, please. This body is not moving, static. It means that for this now, I will have my AS to be 0. Okay, my AS will be 0 since there is no acceleration at all. It means that the sum of these forces, I cannot conclude that the sum of these forces now on this system, on the S direction, is 0. It means that the sum of the what forces will be 0 because the acceleration is 0. Okay, now let me also resolve the one on the vertical. Let me resolve the one on the vertical, which is sigma Fy, and that sigma Fy will be, is going to be, okay, look at it here, we're having the sum of the forces. One is acting upward, the other one is acting downward. This one that is acting upward will be the normal force, and that normal force is Fn. And which one is acting downward and is facing negative direction, and we have it as W. We have it as what? W. Now, in this case, now we are going to resolve this very one. Remember, I told you that the system is not moving. The body is not moving. Since the body is not moving, it means that the sum of the forces will be zero. Sum of the forces will be zero. And another one again, you must consider, you have to also see that the W is what? Mg. W is mg. Please don't forget that. It means that W is what? Mg, because it's under gravity, means gravity that is affecting it. It becomes what now? At the end, I'm going to be having what will be my final note there. Let me just get a marker so that I can resolve it. Let us see what will be the final note here. Let me rewrite this one again. Let me rewrite this one again. This one is Fn minus mg. Please don't forget W is what? Mg. Please don't forget it because it's affected by what? Gravity. It's affected by what? Gravity. Okay, now let us see now. Taking this one now, I want to make this one the subject. I want to take this one over. When I take it over, I'll be having Fn with the normal force. The normal force will be what? At the end will be what? Mg. Will be what? Mg. How we can see. For this system now, this is what I'm going to be having for this system. Okay, now we are still under that static. Please, we are in static. We are in static. This one we are dealing with static friction. Static what? Friction. Static friction. This one is static friction. Please don't forget. Now we are still static. Let me call this one A. The first one. Okay, let me call that one number 1. Let me call this one number 2. Now, assuming now I decide to push this body, I decide to apply a force on it. Let me try to apply a force on it. But the body is not moving. You must know that the body is not moving. Let me try to apply a force on it. If I try to apply a force on this body, it means that force that I apply will be called applied force, which is the Fa. And now, since I want to apply a force, it means that there will be an opposing force. Meaning, remember I told you that frictional force is a force that opposes motion. It means that there will be a force that will try to oppose this motion, and that force will be what? Static friction. That kind of force will be what? Static friction. That kind of force will be what? Static friction. Now, for what we have here, remember that this one is also acting downward. This one is also acting downward because there is a force that will act downward, which is affected by gravity. And this one will also be acting upward, which is the normal force. We try to act upward. And again, from here, I can resolve. You can see now, I decide to apply now. I want to apply the force now, so that this body can slide. Now, for this body to slide, now, what will I do? I have to resolve this system into 2 components. I will have to resolve this system into 2 components. I will determine the Fy. Let me determine the Fy. To determine the Fy there, I'm going to be having sigma Fy, which is the Fn minus W. Because you can see the W is acting downward. Now, from what we have here, remember the body is not moving. I'm just applying a force so that I can move, but it's not moving. Now, under this one now, it means that the sum of the forces will be 0. And we have in this one we have Fn. Remember I told you that W is what? Mg. It means that in this case now my Fn will be Mg. Please don't forget. My Fn will be Mg, which is the normal force. The normal force will be what? Mg. Okay, since I have solved that one now, let me now also resolve the one of Fx. Let me resolve the one of Fs. It means that Fs will be, okay, which one is the horizontal here? Which one is the horizontal? The horizontal is this 2. It means that see that the Fa is acting to the positive direction. I'm trying to use this one to resolve it. You know this one is plus, this one is minus, this one is plus, this one is minus, this one is for S, this one is for Y. Okay, now from this one now, see the direction to the right hand side. Means that Fa is positive, while the other one Fs, the Fs will be negative because it's trying to oppose the motion. It's trying to what? Oppose the motion. Now from there, remember the body is not moving. Please don't forget the body is not moving. Means that some of the forces, no acceleration is in the body. It means that no acceleration is involved in this body. It means that the sum of the forces should be 0. It means that at this point now, we have Fa, we which is minus Fs, which is minus Fs. Now taking it over, I will now be having Fa equal what? Fs. Fa equal what? Fs. Please don't forget that. Fa equal what? Fs. It means that for a body to slide, please take note, for a body to slide, it means that F applied force must equal static friction. Please don't forget, for a body to slide, applied force must equal static friction. Another thing you must also note is this. For static friction, please, another thing you must note is this. For static friction, it means that for static friction, please don't forget, for static friction, it is either less or equal mu s Fn. Please don't forget. And when you have your Fn, you know what it means. Okay, you can also say that our Fs can also be equal. Say it's either less or equal. It can also be equal or mu s. Fn is what? Mg. Please don't forget. Remember, we have done it before. Look at here. We have done it. Mean that at this point now, I can now see that my applied force here is equal to what? Mu s mg. This one becomes the formula for applied force. Either I use mu s mg or I will say F equal Fs, depending on the one I wish to take. This for the like for now. This one I have just applied what a force. Now, okay, now since I've applied a force, it means that the body now, I want to allow this body to slide. Okay, if I now allow this body to slide, what will now happen? Let us see the next thing that will happen. If I allow the body to slide, let us see what will happen. Definitely happen. Now from here, I think I can clean this part of the board. I can clean this part of the board. I can clean this part of the board. I hope you are done with this. I hope you are done with this. Okay, I can clean this part of the board. Okay. Now, cleaning this part of the board to conclude. Now, here it was not moving, no force was applied. Look at what I obtained. Look at what I obtained. Now, I decided to apply the force so that this body can slide. But the body is not moving yet. I try to apply it. Now, when I try to apply it for this body to move, look at what I obtained. Now, that I've applied it and the body wants to move, it means that what will now happen? And this one will now lead us to the second one, which is the dynamic or kinetic friction. This one will now lead us to dynamic or kinetic friction. Let us look at dynamic, like the other one there, dynamic or kinetic. Dynamic or kinetic. Dynamic or kinetic. Let us see that one, kinetic. Dynamic or kinetic. Okay, now looking at dynamic or kinetic, let us see what will happen. It means that since I've applied a force now, for this body to move, let me call this one number 3. Since I've applied the force to it, for the body to move, it means that what will now happen? It means that this one will be applied force, this one will be applied force, which is the Fa, and there will be a force that will resist it, and that kind of force, if the body is now moving now, become kinetic friction. Please don't forget, this one still remains W, and this one remains Fn, which is the normal force. Okay, from what we have here now, let us see what will happen. It means that from here I can determine my F, I can determine my Fy. My Fy will be, I think, still remain, which is Fn minus W. And at the end, remember the body is not moving vertical. We are pushing it now to move horizontal. It's not moving vertical. Since it's not moving vertical, the sum of the force still remains 0. Therefore, the power of Fn, which is mg. Remember that W is affected by gravity, the power of mg. Now from here, I can make Fn the subject of the formula. I'll be having Fn, which is now equal mg. Please don't forget, which is now equal mg. Now from here, I can also proceed and resolve fx. And what is going to be the fx, which is the horizontal? I'm going to be having what fa. I'll be having fa minus. I'll be having fa minus fk. That is what I will be having there, fk. Now in this case, now what can we do? What can we do? See the body is moving now. Some of the forces on the system will not be what? 0, because there is already an acceleration. It means that this one will go mas equal fa minus fk. Please don't forget that. Now from what we have here, I can make a the subject of the formula. When I make a the subject of the formula, I will have what as, which is going to be what equal fa minus fk. Please don't forget all over n. Don't forget also that I said as is the same as a, which is the acceleration. Therefore, I can say the acceleration of this system now, become Fa minus Fk. This one will be the acceleration of the system all over m, Please don't also forget also in Fk, please don't forget Fk is always equal K Fn. Please don't forget. And this Fk, remember Fn, we have determined it. Remember Fn and Fn, we determined it. And what was it? We say K become what? Mg. Please don't forget. Look at it here. Become what? Mg for the Fn. Now from here, I cannot conclude and see from my acceleration of the system become what Fa, which is applied force minus mu k mg all over n. Please don't forget, this one becomes the acceleration of the system. This is all about frictional force. I think we have discussed so much on frictional force. Please, I would want you to stick with me on this platform so that we can move on to the other aspect of frictional force. We want to see how we can apply frictional force to solve a problem. That is what we want to do next. Thanks for watching, and I wish you all the best. And also, please try and stay with me for the next class. Thank you.